Yeah, man. So basically, you know, again, this is the initiative. We're just gonna go ahead and my goal here is to go ahead and help y'all, you know, help y'all understand some of the theory because I know that's a big part of the CCNA, on contrary to what we do on the day to day. And I think it'll help you, of course, whenever you're troubleshooting, of course, advance your career, what have you. So first things first, I want to go ahead and just jump right into it. Just wanted to make sure I go over the resources. Of course, the CCNA official cert guide and network simulator library. I know they got the books, but again, definitely, I think you guys know the details, you know, from the big ball. So yeah, there's, you can go ahead and freaking get this and you're good. Yeah, this comes with everything in it. And then also, I did reach out and confirm this Renee Moner, dope instructor. He's helping me. He helped me with my CCNP and my CCNA, and now he's helping me with my CCIE because he actually has a CCIE course. So dope dude. He makes it simple. He goes over it like in plain English. He doesn't add all the, you know, Harvard school words about networking. So he keeps it real simple. So it's a $29 monthly subscription, real cheap compared to INE, and he does it honestly better than half of them. Also, this resource, Udemy, Neil Anderson, he was a big part of me getting my CCNA as well. He gives you a schedule, he gives you labs to practice on packet tracer. So that's fun as well. And speaking of packet tracer, not sure if you guys download it, but it's free. All you got to do is have a Cisco account, create a free Cisco account. You download it, boom, you can go ahead and start playing in Cisco packet tracer. So real simple, real simple. And last but not least, the study-ccna.com group of guys from Neil Anderson's group went ahead and created this. So they just go over, you know, if you just need to go ahead and touch on some of these topics, maybe it doesn't make sense, or maybe you're troubleshooting, you're like, all right, how does, you know, something like STP or something like that work? You can go ahead and just touch on these, go in here and say, all right, let me look at maybe network layer or something like that. And you can go ahead and touch on it, and it's real simple, real quick. So that's what I like about it. So let me go ahead and click that. Yeah. Any questions, man, about these resources?
Nah.
Nope.
Cool. All right. Hey, Gil, what's going on? All right, fellas. Cool. All right, we're going to go ahead and jump right into it. So, fellas, I'm not sure if you read chapter 1. If not, dude, it's all cool. This is going to be part 1 because, of course, every chapter is typically big, but I want to give it to y'all in bits and pieces. And you guys just don't have to listen to me, you know, speaking or, you know, talking about theory. If you guys want to stop me and be like, hold on, something doesn't make sense, feel free to stop me at any point. All right?
That's what's up.
Cool. All right. So Gil, I know you can hear me. I know you were asking about the OSI model, networking model. So we're going to touch on that, but first we're going to touch on the TCP/IP networking model. You guys are probably asking, all right, why are we touching on that first? So this is what's actually used by our computers, our phones, or what have you to go ahead and send data from the source to the destination. Okay. So this is how it looks from our PC whenever it's attempting to encapsulate data, you know, go ahead and get our request as end users and say, hey, we want to get to Google. This is the process the model uses to go ahead and get that click from our application and go ahead and send it on the wire. Okay. So again, we have 1, 2, 3, 4, 5, right? 5 layers. We have the application layer, we have transport, right? We have the network layer, we have the data link layer, and we have the physical layer, right? The old TCP/IP model, the data link layer and the physical was the same, but they went ahead and split it up as of recent, right? So application layer, HTTP, POP3, SMTP. So that's not necessarily saying, okay, Outlook is at the application layer. That's not what it's saying. What it's saying is these are the protocols used at this layer. Perfect. So the application is going to interact with the TCP/IP model and say, perfect, I need to interact with the application layer so I can go ahead and send this email that I need to send to Mo. Does that make sense? Cool, I'm gonna take that as a yes. So with that, right, whenever it's gonna go ahead and try to send traffic, right, it's gonna go through each layer. We're gonna talk about encapsulation, the encapsulation layer. I just wanted to go ahead and let you guys take a look at how the model looks. Any questions?
Nah.
None
Cool.
so far.
Cool. So I went ahead and got this infograph, real simple, from the book, right? This is how, this is infograph is explaining how the application layer works, right? Web server Larry is trying to reach out to, web browser Bob, guy maybe at UTC, is trying to reach out to the web server, right? And basically Bob is saying, hey, I need to get to, xyz.com, right? And so the web server is just saying, hey, here it is. That's at a high level how the application layer works, right? Simple enough. I know you guys probably get it. At a low level, right? If we go ahead and take a look at the bottom picture, it's showing, a little bit more detail. Okay, how the packet looks. Okay, it's sending that header, HTTP. Okay, it's sending it back, right? And it's sending more of that packet, right? And so this is give you a little bit more detail of how the TCP/IP model is working, and it's sending traffic between two computers, right? All right, so let's keep rolling, right? So I'm sure you guys saw, right? You guys saw the different layers, right? So there's two different theories, right? As it relates to communication from a source to destination, or two hosts, or two PCs, or what have you, right? And I'm sure you guys seen it when you're troubleshooting or what have you, right? So the theory of same layer interaction as it relates to a networking model or OSI model or what have you, or adjacent layer interaction, right? So we can go ahead and read it word for word from it so we don't get mixed up, right? So same layer interactions on different computers, right? The two computers use a protocol to communicate with the same layer on another computer. The protocol defines a header, right, that communicates what each computer wants to do. The hell does that mean, right? So if Mo, right, I'm going to take it back old school. If Mo has AOL Messenger, right, let's say it uses the application layer, right, and I have AOL Messenger and it uses the application layer, right? We're communicating via the application layer. Does that make sense?
Makes complete sense.
We're talking to each other on the application layer, right? Greg speaks English and I speak English, right?
Yep.
We're speaking on the same wavelength, right? Same level. Simple as that. Does that make sense?
Nah, it makes complete sense.
Now on the flip side, right? So adjacent layer interaction on the same computer, not on different computers. Adjacent layer interaction on the same computer. So basically, one layer of the model talking to or working with another layer of the model, right? That's a theory in itself, because that's how packets leave Mo's computer. If Mo wants to go ahead and send a message to me to say, hey Dave, wake up, you're late for work. You know what I mean? So we have the application layer, right? So we're on Mo's PC. Mo interacts with AOL Messenger. Hey Dave, wake up for work, right? So his computer says, all right, cool, I need to send this packet out. I need to send this to Dave, right? Where does this need to go? All right, I need to go ahead and go to Dave, and I'll make sure he needs to get there reliably. It's going to use the application layer. It's going to use let's go back. It's going to use application, say, all right, I need to make sure, do I need to send it reliably or unreliably, right? TCP or UDP, right? And don't stress yourself out if all these, acronyms and stuff don't make sense. It's going to make sense later, right? So again, Mo's message is still trying to come to me. The PC is going to say, all right, cool. I need to go ahead and see what's Mo's computer's IP address. What is his default gateway? You guys know what that term means. You guys seen it before. Cool. I know where to send it. Perfect. What's Mo's MAC address, right? As it relates to his adapter on his Ethernet adapter on his PC, or if he has Wi-Fi, right? Wi-Fi adapter. What's that MAC address, right? Because that's how that traffic gets sent on the wire, right? That's how the switch know, or the devices talk to each other, first they have to talk at the data link layer, right? And then, right, once Mo's PC knows all of that, it's going to say, perfect. I can go ahead and translate all of this whole package of Mo trying to tell Dave to wake up through AOL Messenger. I can go ahead and turn it into the physical layer, ones and zeros. I can go ahead and transfer it on the wire or through the air using Wi-Fi, right? So that's it, right? And that's typically how it works. Let's go back. Does that make sense? As far as how the adjacent layer interaction happens on the same computer.
Yeah, I'm with you.
Cool. All right. So my favorite layer, I think you guys know, right? The network layer, right? And this has to do with the IP addressing and the routing of packets, right? So with the CCNA or Cisco, Extreme Networks, Aruba, what have you, right? They follow all the same theory, right? Is to go ahead and make sure, if we're using me and Mo's example, if Mo's message to me wants to get to me, right? I may be in Florida. Mo may be in Oregon, right? That how does it get to me, right? So we have a series of routers, right? Routers that work all together to go ahead and make sure, hey Mo, your message that you're trying to send to Dave, we're going to go ahead and take care of it and make sure it gets to him, right? And typically how, most computer sends it to his router, and of course his WAN provider sends it right to the destination, right? And they're all little routers that work for ISPs, and they all work together to go ahead and interconnect, all willy-nilly to go ahead and make sure it gets to the destination. You'll always hear me say about the network layer, the only thing about the network layer that you guys need to remember is IP addressing and a source and a destination, right? In the second part, you have to remember that for the data link layer as well, or the Ethernet layer, right? But with everything, as far as it relates to layer 3 and down, the source to the destination, that's it, right? And it can relate to it as if it's, the postal service, right? So if, again, we're on Mo's computer, he's trying to go ahead and send something to me. All these different, let me get my handy dandy note. Let me see, they make it red. There we go. Mo's right here, right? And his ISP is right here. That ISP is going to go ahead and do the hard work, right? Just like how if he's shipping a package to your family or friends or what have you, it's going to go ahead and work together and it knows where to go to. That's typically how routers work. And that's how the network layer works. It's going to go ahead and say, hey, I have a source, I have a destination. Where does this need to go? Simple as that. That's exactly how it works. Does that make any sense? Anybody have any questions?
No, I get it.
Okay, cool. All right, stop me at any time. Let's go ahead and keep going. There we go. Let me erase that. Hold on. All right, there we go. All right. Get all this out of here. Boom. I see a few people joined. Guys, just to let you guys know, we're just going over the TCP IP networking model. We haven't touched on the OSI model yet. So the TCP IP network model, that's actually what's used on our computers right now, right? At a later session, we're going to go ahead and talk about the OSI model, right? That is a reference model, right? But it actually makes sense to where if you're troubleshooting or if you're trying to understand how packets travel from source to its destination, okay? And how adjacent layer interaction happens and how same layer interaction happens, right? But that's going to be another session because, again, I don't want to overload you guys with too much information in one session, okay? Go to the next page. Cool. So, again, same example between me and Mo, right? He's trying to go ahead and send a packet to me, right? And of course, the router is going to do its job, right? His PC is going to do its job. It's going to send it to its default gateway right here, okay? So it's going to send it here. And then the routers, right? We're going to call it the ISP routers. Is going to know where to send it to. That's it, right? Because all its job is trying to understand what's the source and how do I get to the destination. And I'm just going to tell you how to go and where to get it and how to get there. Make sense? Cool. All right. Let me go ahead and keep rolling. And guys, at any time, stop me. All right. Now that we're out of the network layer, we're going to go ahead and touch on, and like I told you guys, the TCP/IP model. They went ahead and put together the data link layer and the physical layer, right? Data link, right? We're talking about MAC addresses. We're talking about how switches handle that traffic between the same broadcast domain, right? If you don't know what that means, we'll talk about it in a later session, right? But again, there's an Ethernet header and an Ethernet trailer, right? And that Ethernet header is typically, it's displaying, hey, what's that source address and destination address for this frame, right? Because it's not going to be called a packet anymore. When it gets to that data link layer, it's going to be called a frame, right? So this is typically at a high level how it looks, right? Mo, we're going to call Mo Larry, right? So for Mo's PC, he's trying to go ahead and send that packet to me, but first it has to go through his router, right? So what it's doing, that packet, right? And right, because it came from the application layer, it went through those other layers. Now it's an IP packet. But now to go ahead, before it gets on to the wire, to go ahead and send it out from his house, it needs to go ahead and become a frame, right? We need to know the MAC address because switches and all that operate at layer 2, right? And they need to know what's his actual address of his hardware PC, that NIC card on his PC. So the PC is going to go ahead and encapsulate that and say, all right, here's Mo's MAC address 000.0050.06665, right? That's his MAC address. And of course, the destination would be R1's MAC address on that interface. And that's typically what the data link layer is, right? In the physical layer, right? If we're still talking about the same infograph, the physical layer is just this. The cable, the media, whatever is used to go ahead and transfer that packet, that frame from the source to the destination. That can be Ethernet cable. That can be, air communication via Wi-Fi. That can be a fiber connection, etc. Right? That can be another thing in layer 1 of the physical layer can be the PC, right? It can be keyboards, mouse, all that. Whenever you hear somebody in text say layer 1, that's what they mean, right? Anything that end user has to interface with, right? So that's it. Let me go ahead and let's go to the next one. And remember, guys, earlier I talked about encapsulation and de-encapsulation, right? So again, this just explains what that infograph I told you guys about what happens, right? And let's read it step by step, right? Step 1, right? If we're looking at Larry, right? Here's Larry, right? AKA Mo, right? Larry encapsulates the IP packet between an Ethernet header and Ethernet trailer, creating an Ethernet frame. Larry physically transmits the bits, right? Because that's what it's called, of this Ethernet frame. Now it's Ethernet frame using electricity flowing over the Ethernet cable, right? So we've seen Ethernet cables before. I'm sure all you guys have. All that is just copper cables transmitting electricity. And it's basically just ones and zeros going over that cable. Smart guys, whoever created this, right? Then router 1 physically receives the electrical signal over a cable and then recreates the same bits, right? By interpreting the meaning of the electrical signals. So it gets it, right? So Mo's router, right, gets those bits that were received by Mo's PC and says, oh, I know what these means. I can go ahead and decode this. Perfect. Boom, right? And then step 4, router 1 starts to de-encapsulate, meaning that it starts to break off a few things. So these headers, the Ethernet header and trailer, gets broken off, right? And now the router, right? And we're going to talk about the different layers, but routers typically only work at layer 3, which is the network layer. So it's not going to send traffic to a destination or a source based on the Ethernet, right? Based on anything at layer 2. It's just going to be touched on layer 3, right? So it's going to take those off and say, all right, I just worry about this. I'm not worried about the application layer, transport layer. I'm only worried about the IP packet layer. All right, where does it need to go? I'm going to go ahead and send it. That's it. That makes sense?
Yeah, it does. Is it only, I mean, I think you mentioned it before, but I just want to make sure the data link and physical layers are the only ones that the IP packet gets encapsulated in?
Say it again.
The data link and physical layers, those are the only times that like the IP packet gets encapsulated and turns into a frame?
That's a good question. That's a good question. So let me go to the next slide. I think it's going to make sense. Give me 1 second, okay?
Yeah, my bad.
No, dude, come on. You good. This is what we're here for, right? So, Greg, stay with me, okay? So the encapsulation process, it happens at each layer. You know what I mean? So, right? So we have the data, right? That's at the application layer. But we can't send it on the wire just by looking at that that application layer protocols. It has to go ahead and get encapsulated, right? So boom, it's encapsulated by the transport layer protocol, right? So then it's encapsulated again. The network layer protocols, boom, it's bundled up. Then it's bundled up again. Data link and physical layer, right? And we're going to call this the data link layer, right? Because even though theoretically they bunch it up, and we'll look at a packet capture in a second, even though they bunch it up, right, it's still only just the data link layer in itself. And then the physical layer is just whenever it just gets onto the wire, whenever it gets onto that copper cable or wireless adapter before it shoots it out. Does that make sense? So every layer is encapsulated.
That makes a lot more sense after seeing the chart and you breaking it down, for sure. Yeah.
Okay. All right. And the same thing in the reverse, right? We got encapsulation and de-encapsulation. So for Mo's PC, it's going to go ahead and encapsulate, right? But then on my PC, since I'm on the receiver side, I'm the destination, I'm going to go ahead and de-encapsulate because I'm saying, okay, what did Mo send me, dude? You know, he maybe send me a link to get a free PS5. You know, it might be spam, but whatever. I'm going to de-encapsulate it, right? So that's what my PC, that's what the destination or the host on the other side is going to do. Does that make sense?
No, it makes complete sense. You got to encapsulate it to send it to the other person, and then once they receive it, de-encapsulate it to understand the data.
There we go. That's it.
Okay.
That's it. Okay. Now, real quick break, right? And I know you guys will hear me say some of these big words, right? I'll go high level meaning I'll try to make it simple, low level meaning in detail. I'm going to do that because I know these big words can be a lot. They were a lot for me, but you know, we got to truck through it because whenever you guys get on the exam, Cisco and a lot of other vendors, they like to test their candidates to make sure that they understand the theory, what have you. So they're going to use those big words. So if I ever use those big network terms or what have you, go ahead and feel free to say, hey, Dave, I know it's the 4th or 5th time that I'm asking you this. But what the hell does data link mean? What does transport mean? And I'm more than happy to explain it. But after a while, I'm going to, you know, hold you guys to a standard and say, hey, all right, what does that mean? That make sense? Is that fair? Cool. All right. Well, hopefully, guys, that de-encapsulation and encapsulation breakdown made sense. And again, this is just another breakdown of how it works. And this is a great slide, so I can go ahead and go in detail, right? I know you guys will hear, you guys heard me earlier say, okay, when it's at the network layer, it's a packet, right? But when it's at the data link layer, it's a frame, right? I just want you to take a screenshot of this. Don't wreck your brain right now about this, right? Because whenever we do our labs, I'm going to show you how that looks, right? And why it's okay, it's a packet rather than a frame, right? So I want you guys to just go ahead and just take a screenshot of this, save it for your notes. We'll talk about this junk later. Make sense?
Yes.
Cool. All right. And with that, fellas, that is it. Guys, any questions?
That's a bad motherfucker with that sword and that flame.
So
Don't want no
goofy.
part of him.
So goofy. So goofy. So, guys, again, this is the CCNA Initiative. Again, this first session, I didn't want to hang on to you guys too long. the next session, of course, we'll go over part 2 of chapter 1. Please read it. Please go over it. If you don't go over it, it's totally up to you. Again, I'm not going to slow down this process. And again, the fun days will be Friday. So Fridays we'll be doing labs, and I'm going to send you these labs, and also I'll go ahead and do those labs at EVNG. All right. Any questions, guys?
Nope.
Appreciate you, Dave. This is
All right,
meaningful.
guys.
Appreciate it.
Nah, no problem.
Yeah, man.
No problem. All right, guys.
Appreciate
well,
you, David.
this will be uploaded on YouTube shortly. So feel free to share with whoever missed it, and I'll see you guys on Thursday.
Absolutely.
guys.
Thank you.
Thanks, David.
All right, guys.
Hey, bye.
Later.
Thank you. Later.
Appreciate it.